October 3rd, 2025. Right now, multiple spacecraft positioned around Mars are directing their cameras towards something that defies explanation. An entity expelling 150 kilograms of gas each second with absolutely no discernible propellant force. It's akin to observing a cannon discharged without any observable backward momentum. This phenomenon represents such a fundamental transgression of natural laws that when researchers first encountered the data, they genuinely suspected their instruments were malfunctioning. However, they were not. Avi Lobo of Harvard University has assigned it a rating of 6 out of 10 on his proprietary scale for alien technological signatures. Yet, that is not the primary reason for your attention. You are here because 2 days prior, an individual claiming affiliation with the European Space Agency disseminated information on the online forum 4chan. The leak contained technical details expressed with a palpable sense of frustration. The author described a formal scientific working group that had attempted, without success, to categorize this object within any known class of naturally occurring celestial bodies. The quoted sentiment was, "This position is no longer tenable, and the silence from leadership regarding the cognitive dissonance this requires is becoming a serious professional issue." They also alluded to chemical compositions that should not be physically feasible. Specifically, nickel tetracarbonyl, a synthetic industrial compound being emitted from a rocky mass presumed to be billions of years old. The particulate matter is so unusual that it necessitated an entire week of instrument recalibration before the measurements could be deemed reliable. Furthermore, there is a significant mass discrepancy. An estimated 33 billion tons compressed within a 3-kilometer radius. The statistical improbability of such a configuration is so profound that it implies either our galactic models are incorrect by a factor of 10,000, or this object is not merely cosmic detritus. But consider this. It becomes even more perplexing. In 26 days, it will vanish behind the sun, its observational window obscured from every telescope on Earth. And when it reappears in December, we will ascertain if its trajectory has altered. Because if it has, no natural phenomenon can account for such a deviation. There exists a theoretical framework, one that sounds like speculative fiction, yet offers an explanation for every observed anomaly. The gas expulsion without resultant thrust, the synthetic chemical signatures, the thermal impossibilities, and an object possessing its own intrinsic propulsion system, not fueled by solar energy, but by something originating from the very inception of the universe itself. And critically, this theory is empirically verifiable. It presents 2 distinct predictions, both of which are falsifiable, and both anticipated within the next 3 months. This is 3 Atlas, the 3rd known object of interstellar origin ever detected, and it is the first one that has compelled scientists to question whether they are observing a comet or something deliberately masquerading as one. By the conclusion of this discourse, you will comprehend why certain researchers are experiencing sleepless nights, why its trajectory appears deliberately engineered, why the timing seems too precise, and what the implications will be if the empirical data continues to defy conventional understanding, because the facade is crumbling, and the true nature of this phenomenon is beginning to reveal itself. If you are prepared, please indicate your engagement by liking this video and subscribing, as this narrative is unfolding in real time, and kindly share in the comments where you are accessing this information from, what time it is in your location, and the most peculiar event you have ever experienced. Chapter 1. The Mars Moment. Something is transpewing at this very instant. Not tomorrow. Not in some distant future scenario where we finally develop the requisite telescopic technology or dispatch the appropriate exploratory probes. Right now. Today. October 3rd, 2025. At precisely this moment, humanity has multiple spacecraft strategically positioned in orbit around Mars, and every single one of these instruments is actively engaged in attempting to capture photographic imagery of the same celestial entity. This object is designated 3I Atlas, recognized as the third confirmed interstellar visitor to our solar system. And at 400 Universal Time this morning, it traversed a distance of 29 million kilometers from Mars. This marks the closest proximity it will achieve to any planetary body during its entire transit through our cosmic vicinity. The timing of this passage is of paramount importance. Let me elucidate the reasons behind this significance. For the preceding 3 months, astronomers have been meticulously observing this object utilizing Earth-based telescopes. The Hubble Space Telescope provided imagery. The James Webb Space Telescope conducted an analysis of its chemical composition. Numerous observatories across the globe have been diligently tracking its movement. However, a considerable impediment exists with all of this collected data: distance. When the Hubble telescope photographed 3 Atlas on July 21st, the comet was situated 446 million kilometers away. This is approximately 3 times the average distance between the Earth and the Sun. At such a vast range, even Hubble's extraordinarily advanced optical capabilities can only discern a limited degree of detail. But today, a pivotal change has occurred. The Mars Reconnaissance Orbiter, equipped with its high-resolution camera, is now 20 times closer to 3 Atlas than Hubble was during its observational period. 20 times closer. The resultant difference in image resolution is simply staggering. Where Hubble was capable of detecting little more than a nebulous mass enveloped in dust, the high-resolution imaging science experiment, HiRISE camera, should be able to resolve features down to 30 kilometers per pixel. If the object's dimensions are indeed as substantial as some preliminary calculations suggest, potentially 5 kilometers or more in diameter, we should be able to discern discernible structures, a defined shape, and perhaps even surface topography. The European Space Agency is also actively participating in these observations. 2 of their spacecraft, Mars Express and the ExoMars Trace Gas Orbiter, have redirected their sophisticated instruments towards the comet. Mars Express carries the high-resolution stereo camera. The ExoMars Trace Gas Orbiter is equipped with the color and stereo surface imaging system. Both of these instruments were originally designed for the detailed photographic survey of the Martian surface, but for this exceedingly brief observational window, they are being utilized to scrutinize something far more unconventional. Furthermore, there are the spectrometers. Mars Express is equipped with the Omega and Cassis instruments. The ExoMars Trace Gas Orbiter features the Nomad instrument. These instruments do not merely capture visual images. They meticulously measure the light emanating from celestial objects. Specifically, they dissect the light reflected or emitted by an object into its constituent wavelengths. This detailed data provides crucial insights into its chemical makeup, identifying present molecules, ascertaining temperature ranges, and determining whether the observed activity is a consequence of ice sublimation or an entirely different underlying process. The official aspiration is that these intensified observations will definitively resolve several fundamental inquiries. What is the true size of the nucleus? Is it in a state of rotation? If so, what is its rotational velocity? What does the surrounding dust cloud visually resemble when observed at such close proximity? And most crucially, is this simply an exceptionally large comet exhibiting unusual behaviors? Or is there an intrinsic, fundamental difference in this object's nature? Because therein lies the critical point of contention. Based solely on its apparent brightness, when 3 Atlas was initially discovered in July, Astronomers estimated its diameter could be as large as 20 kilometers. Subsequently, as more refined data became available from the Vera C. Rubin Observatory, that estimation was revised downward to 10 kilometers. Further observations by Hubble in late July suggested a diameter of perhaps 5.6 kilometers. And certain theoretical models, contingent upon the reflectivity of its surface, indicate it could be as small as 440 meters. This represents an enormous range of potential sizes, from 20 kilometers down to less than half a kilometer. The distinction is comparable to the difference between a small city and a substantial building, and the accurate determination of its size is of immense consequence. If 3I Atlas is genuinely 5 kilometers or larger, it would indisputably establish it as the most massive interstellar object ever detected by several orders of magnitude. The initial interstellar visitor, Oumuamua, was estimated to be approximately 100 meters across, with a shape resembling a flattened disk tumbling through space. The second such object, 2I Borisov, was estimated to be around 600 meters, appearing as a relatively conventional comet. But a 5-kilometer object, weighing 33 billion tons, is not merely large. It presents a profound statistical anomaly. Allow me to contextualize this. Our current theoretical models regarding the formation of interstellar objects posit that smaller fragments should vastly outnumber larger ones. For every massive, mountain-sized rocky body ejected from a distant solar system, there should be tens of thousands of pebble-sized fragments, potentially hundreds of thousands. The probability of detection is heavily biased towards smaller objects appearing first, simply due to their sheer abundance. Yet, here we stand. 3 interstellar objects have been detected to date, and the third one possesses a potential mass that is between 1,000 and 1,000,000 times greater than the first. This is an inversion of expectations. Unless our existing models are fundamentally flawed, unless the galaxy is not merely sparsely populated with interstellar debris, but rather teeming with it, unless the processes responsible for ejecting material from solar systems are vastly different from our current understanding, or unless this object is not debris at all. This is precisely the question that the Mars observations are intended to help resolve. If the HiRISE camera captures a clear image revealing a 5-kilometer nucleus, the mass estimations will hold true. 33 billion tons will become a definitive lower boundary, and at that juncture, the statistical anomaly will become undeniably unavoidable. Conversely, if the image depicts something smaller, perhaps a kilometer or less in diameter, then the mystery fundamentally shifts, because a smaller nucleus, exhibiting the observed brightness and outgassing rates, would imply that the object is extraordinarily active, expelling a significantly greater volume of material than any known comet at comparable distances from the Sun. In either scenario, something simply does not compute. Now, here is the particularly frustrating aspect of this situation. We will not have immediate answers. The collected data must first be transmitted back to Earth. Subsequently, it must undergo rigorous processing and analysis, followed by cross-verification. The European Space Agency has already indicated that they do not anticipate obtaining spectacular images from the Mars Express and ExoMars Trace Gas Orbiter. Both of these spacecraft are engineered for the purpose of observing the Martian surface from above, not for deep space astronomical observation. At a distance of 30 million kilometers, 3I Atlas will appear as less than a single pixel within their camera's field of view. They might capture the luminous halo of gas surrounding it, perhaps a faint indication of its tail, but the nucleus itself will likely remain undetectable. The HiRISE camera represents the genuine hope for detailed imagery But even then, the timeline for its release remains uncertain. It could take days, perhaps even weeks, before processed images are made publicly available. And during this interval, the object continues its relentless journey. By mid-October, 3I Atlas will have moved too close to the Sun to be observed from Earth. The intense glare will render it invisible. It will reach its perihelion, its closest orbital point to the Sun, on October 29th, at 1.4 astronomical units, positioning it just inside the orbit of Mars. And throughout the entire period from mid-October to the end of the month, the object will be situated on the opposite side of the Sun from Earth, completely obscured and unobservable. This represents a period of 26 days, nearly an entire month. And when it re-emerges in the pre-dawn sky in early December, we will finally be able to observe it once more. We will be able to reassess its trajectory, measure its brightness, and confirm whether it behaved as a typical comet during its passage through perihelion, or if something entirely unexpected transpired. But let us return to the present moment, October 3rd, the Mars moment. Because while the officially sanctioned narrative centers on resolving the question of its size, there exists another, deeper layer to this unfolding story. A layer that is less concerned with what the cameras will ultimately capture and more focused on what the data has already definitively revealed. And it is precisely at this juncture that the established paradigms begin to falter. Chapter 2. The 7 Transgressions Against Nature. Avi published a scholarly article on October 3rd, coinciding precisely with the Mars flyby. The timing of this publication was clearly intentional. Within this paper, he meticulously outlines what he has termed the 7 anomalies of 3 Atlas. It is important to note that he does not refer to them as ambiguities or mere curiosities, but rather as anomalies, behaviors and characteristics that fundamentally deviate from the established scientific model of what constitutes an interstellar comet. He has categorized these anomalies into 2 distinct groups. The first category encompasses 4 anomalies that possess the potential for explanation or mitigation through the acquisition of more comprehensive data. The second category comprises 3 anomalies that, in his own words, will remain puzzling forever because they are not dependent on a lack of information. Instead, they pertain to probabilities, trajectories, and temporal alignments that strongly suggest a purpose beyond mere random chance. Let us commence with the first category, the potentially explainable anomalies. Anomaly 1. Size. We have already touched upon this significant point. The apparent diameter of 3 Atlas exceeds 5 kilometers, imputing a minimum mass of 33 billion tons. This renders it between 1,000 and 1 million times more massive than the 2 preceding interstellar objects. The potential for explanation here hinges directly on whether future observational endeavors, such as today's Mars flyby, will conclusively confirm or necessitate a revision of this figure. If the nucleus is ultimately found to be smaller, the anomaly's impact is diminished. However, if it is confirmed to be 5 kilometers or larger, the statistical problem becomes substantially more pronounced. Anomaly 2. The jet. Imagery obtained by the Hubble Space Telescope reveals a peculiar feature: a forward-facing jet of scattered sunlight, measuring 10 times its width in length and oriented directly towards the Sun. The vast majority of comets exhibit tails that stream away from the Sun, propelled by the solar wind and radiation pressure. However, this particular jet is oriented in the opposite direction. The proposed explanation posits that 3 Atlas is experiencing a vigorous outgassing event on its sunward side, releasing material that reflects solar illumination before being propelled backward. This is, on the surface, plausible. But here lies the critical caveat. This jet appeared remarkably early in its trajectory, at distances where most comets typically remain dormant, and it maintained an unusually bright and persistent presence. A less pronounced tail did indeed become apparent by late August, but only after the object had moved significantly closer to the Sun. This delay in tail formation is peculiar. It suggests that the dynamics of its outgassing are not adhering to the behavior patterns of a typical comet. Anomaly 3. Chemical composition. This is where the observations transition from peculiar to genuinely inexplicable. Spectroscopic analyses conducted by the James Webb Space Telescope and the Very Large Telescope have indicated that the gaseous plume surrounding 3E Atlas contains a significantly higher proportion of nickel than iron. In the case of conventional comets, and even in the preceding interstellar comet 2I Borisov, nickel and iron are present in ratios that closely mirror those observed in the Sun, roughly balanced. However, 3I Atlas exhibits an extreme dominance of nickel. Nickel was detected at every observational epoch. Iron, conversely, only became measurable when the object was situated within 2.64 astronomical units from the Sun. And even then, the ratio of nickel to iron remained substantially higher than anticipated. The significance of this observation lies in the fact that nickel and iron are refractory metals. They do not readily sublimate, meaning they do not transition from a solid to a gaseous state at the low temperatures typically found on comets. The surface temperature of 3 Atlas, even when relatively proximate to the Sun, is too frigid for raw nickel to simply vaporize. This implies that an alternative mechanism must be at play. Either there exists a parent molecule, a compound containing nickel that subsequently breaks down to release nickel atoms, or the heating process itself is unconventional. In either scenario, the situation presents a significant enigma, and there is further complexity. The composition of the expelled gas is also unusual. Most comets are predominantly rich in water. As they approach the Sun, water ice sublimates, and its spectral signature becomes the most prominent. However, 3I Atlas is characterized by a high abundance of carbon dioxide. The ratio of carbon dioxide to water is a staggering 8:1. This suggests that the object originated in an exceedingly cold environment, significantly colder than the regions where typical solar system comets are formed. Anomaly 4. Polarization. This particular anomaly, while technical in nature, carries significant weight. When light reflects off dust particles, it undergoes polarization. The degree and orientation of this polarization provide crucial information about the size, shape, and surface texture of these particles. Every comet and asteroid that has been subjected to scientific study falls within a predictable and consistent range of polarization values. 3 Atlas, however, deviates entirely from this established spectrum. The polarization data returned results so far outside the expected parameters that the research team initially suspected an instrumental error. They meticulously repeated the measurements, yielding the same outcome. The only plausible explanation for these anomalous figures is that the dust grains themselves possess fundamentally different characteristics. They are not composed of typical silicate compounds or water ice crystals, but rather something entirely novel. These particles are hypothesized to be large, complex structures, highly porous, exhibiting a smoky texture. Now, here is the critical point. While these 4 anomalies are indeed peculiar, they do not, in themselves, definitively invalidate the hypothesis that 3 Atlas is a comet. Future, more precise data might clarify its size. The observed jet could potentially be attributed to a rare but natural asymmetry in its outgassing process. The presence of nickel might be explained by an exotic parent molecule that has yet to be identified. The unusual dust composition could be a byproduct of exceptionally unique formation conditions. These explanations, while perhaps uncomfortable, are not inherently impossible to reconcile. However, we then proceed to the second category, the anomalies that present permanent mysteries. Anomaly 5. Trajectory alignment. The orbital path of 3 Atlas demonstrates an alignment with the ecliptic plane, the flat disk within which planets orbit the Sun, to within a mere 5 degrees. The vast majority of interstellar objects arriving from random points within the galaxy would be expected to possess random inclinations, some steep, some shallow, some even retrograde. The statistical probability of an object arriving on a trajectory so closely aligned with the planetary plane purely by chance is approximately 0.2%, or 1 in 500. While not an absolute impossibility, as rare events do occur, this represents the first significant red flag. Anomaly 6. Arrival timing. This is where the probability plummets dramatically. 3 Atlas did not merely arrive on a trajectory aligned with the planetary orbits. It arrived at a specific time that facilitates close encounters with Mars, Venus, and Jupiter. Specifically, the object is scheduled to pass Mars today, October 3rd. It could have reached Venus with minimal course correction in July, and it is presently positioned for a relatively close pass by Jupiter in March of 2026. The probability of an interstellar object randomly arriving on a trajectory and at a time that permits such coordinated encounters is approximately 0.005%, or 1 in 20,000. Consider this for a moment. If one were to design a spacecraft intended to visit multiple planets within a solar system, the logical approach would be to plot a trajectory that intersects their orbital paths. One would carefully time the arrival to coincide with the planet's positions, thereby minimizing the fuel required for trajectory adjustments. This is precisely the methodology employed in the design of human space missions. Consider projects like Voyager or New Horizons. They meticulously optimized trajectories and utilized gravitational assists. 3 Atlas appears as if it were deliberately delivered. Chapter 3. The impossible physics. 2 days ago, a significant development occurred. On October 1st, 2025, an anonymous post appeared on the online forum 4chan, not within a scientific discussion board or on a preprint server, but rather on 4chan's paranormal board, a section more typically associated with internet folklore than with legitimate scientific discourse. However, this was not folklore. The individual who posted claimed to be a doctoral researcher affiliated with the European Space Agency. They asserted possessing ongoing access to the consolidated observational data pertaining to 3I Atlas, and stated they were an integral part of a formal working group tasked with understanding this object, a group that had, according to their claim, failed in its objective. The exact quotation read, "For months, I've been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. The official position is that 3 Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us." Now, to be unequivocally clear, anonymous posts on 4chan do not constitute peer-reviewed scientific findings. They are not independently verified. Such submissions could very well be elaborate fabrications, role-playing scenarios, or the work of an individual who has perused scientific literature and decided to instigate speculative discourse. However, here is what distinguishes this particular post. the level of technical detail presented is exceptionally high. The tone of frustration conveyed appears genuinely authentic, and the claims made align disturbingly well with publicly accessible data, while also introducing contextual information that has not been disclosed in any official release. Therefore, I will proceed to outline the assertions made in this post, not as established fact, but as a glimpse into the potential behind-the-scenes deliberations occurring when scientists confront empirical data that stubbornly defies conventional interpretation. The post commences with a discussion of outgassing. 3 Atlas is observed to be expelling approximately 150 kilograms of gas and dust every second. This is not mere conjecture. It is a measurable phenomenon. The James Webb Space Telescope has provided evidence of this, and spectrometers at the Very Large Telescope have corroborated these findings. The object is hemorrhaging material at an alarming rate. Carbon dioxide, water ice, and dust particles are being released continuously and with immense force. And according to this purported researcher, this activity has no observable consequence. The quote continues, "It feels like a mistake in the data until you've checked it 100 times with all the available instruments. The object is venting about 150 kilograms of gas and dust every single second. We see it, yet it does nothing. It's like watching a howitzer fire a shell with absolutely zero recoil or smoke or bang. It's a constant violent event with no consequences, and that is a disgusting violation of basic physics." Let me elaborate on why this presents such a profound problem. When a comet releases gas, it inherently experiences a reactive thrust. This is a direct consequence of Newton's third law of motion. For every action, there is an equal and opposite reaction. The expelled gas moves away from the surface, and consequently, the comet recoils. While this recoil is minuscule, it is measurable over time. This phenomenon is responsible for what astronomers refer to as non-gravitational acceleration, a slight deviation from a purely gravitational trajectory. Every active comet exhibits this effect. Halley's comet, Comet Hale-Bopp, the previous interstellar visitor, 2I Borisov, all of them demonstrated measurable non-gravitational acceleration as they outgassed in proximity to the Sun. 3 Atlas, however, exhibits virtually none of this expected acceleration. A paper published in September, authored by Richard K. Wallace, Avi Loeb, and Peter Vers, analyzed 4,022 positional observations from 227 observatories worldwide, collected between May and September. They meticulously calculated the object's trajectory with exceptional precision. Subsequently, they searched for any deviations, any residual movements, any indication that the outgassing was perturbing the object's course. The upper limit they determined for this non-gravitational acceleration was 0.28 arcseconds over several months of observation. This corresponds to a non-gravitational acceleration of less than 15 meters per day squared. For an object venting 150 kilograms per second, this value is impossibly small, effectively negligible. The principles of physics, as presented by the source, indicate that the celestial body in question possesses a mass significantly exceeding its apparent size. To be precise, it suggested that the object must contain the equivalent mass of a small moon, compressed within a diameter no greater than 2 to 3 kilometers. Previous estimations yielded a minimum mass of 33 billion tons, which unfortunately introduces a distinct and even more problematic scenario. The statistical improbability of encountering a mountain-sized object on an interstellar path is exceedingly high. Consider the implications. If the object, identified as 3I Atlas, has sufficient mass to counteract the recoil from expelling 150 kilograms per second, it must be extraordinarily dense. This density would surpass that of ice or rock, approaching the massiveness of iron. A sphere composed entirely of solid nickel iron, measuring 3 kilometers in diameter, would approximate this required mass. However, this object does not present as a metallic asteroid. It exhibits a coma and a tail, actively outgassing like a comet. Therefore, the necessary mass must be present, yet it must somehow coexist with volatile ices on its surface. The original text elaborates, stating that their astronomical surveys have only just begun. The discovery of such a massive object so early in their observations implies that the galaxy is not merely sparsely populated with debris, but rather teeming with such entities. This suggests that current models are inaccurate by a factor of 10,000, and our comprehension of material ejected from solar systems is fundamentally and drastically flawed. The ultimate realization is that this object might not be debris at all. This is the quiet, unsettling conclusion that is being discouraged from open discussion. Let this sink in for a moment. If the mass estimation, 33 billion tons or more, is accurate, then the statistical models fail because large interstellar bodies should be exceedingly rare, exponentially less common than smaller ones. For every object the size of a mountain, there should logically be millions of smaller particles. Yet, so far, 3 interstellar objects have been detected: a small, flattened object, a comet behaving in a typical manner, and now something 1,000 times more substantial. This sequence is reversed from expectations. Either an astronomically improbable stroke of luck has occurred, or the galaxy harbors a far greater abundance of massive interstellar objects than previously conceived, by orders of magnitude. This would necessitate a fundamental reevaluation of our understanding of planetary system formation and the mechanisms by which material is expelled into interstellar space. Alternatively, there is a third possibility. This object is not debris. However, this leads to further complications. According to the source document, the chemical composition also defies conventional understanding. The text states, "When you examine what is actually present in the gas, the situation deteriorates. We are observing pure atomic nickel being emitted as vapor. This is occurring at temperatures where it should remain frozen solid. This is not a gradual process, akin to ice turning into vapor. It's an abrupt transition. The emission of nickel is astonishingly sensitive to sunlight. A minor alteration in heat input causes it to cease entirely. There is only one plausible explanation for this behavior: the decomposition of a parent molecule. The sole candidate is nickel tetracarbonyl, a substance employed in industrial refining processes. This explains all observed phenomena, particularly the absence of iron. However, it is not a naturally occurring compound. The presence of a synthetic chemical on a celestial body believed to have existed in space for billions of years is profoundly perplexing. Nickel tetracarbonyl. Let us consider this compound for a moment. It is represented by a chemical formula. Nickel atoms are bonded to 4 carbon monoxide molecules. At ambient temperatures, it exists as a colorless, highly toxic, and extremely volatile liquid. It was first identified in 1890 by a chemist named Ludwig Mond. We utilize it in industrial applications through a process known as the Mond process, employed for purifying metallic nickel. Impure nickel is exposed to carbon monoxide gas under specific conditions, leading to the formation of nickel tetracarbonyl. Subsequently, this compound is heated, causing it to decompose and deposit pure nickel. It is a synthetic substance, manufactured in laboratories and refineries, and does not occur naturally on Earth. According to this researcher, It is the only compound that accounts for the nickel emission profile observed from 3I Atlas, including its temperature sensitivity, its intermittent behavior, and the lack of iron. However, if nickel tetracarbonyl is present on a comet estimated to be billions of years old and formed within a primordial planetary disk, how did it get there? Natural processes do not produce nickel tetracarbonyl. It requires specific conditions, namely high-pressure carbon monoxide interacting with metallic nickel. Furthermore, even if these conditions were present in the early solar system, the compound is inherently unstable and would decompose over time. It could not survive billions of years in interstellar space. This leads to the conclusion that it must be actively generated, which raises an even more extraordinary question. Generated by what? The source then shifts its focus to the dust particles. It states, "And the dust it is shedding is equally problematic. We analyze the way light reflects off it. Its polarization provides insights into the texture of the particles. Every comet and asteroid encountered thus far exhibits characteristics within a defined range. The data from this object deviates so significantly from expectations that our director insisted for nearly a week that we were making errors, until we managed to replicate the results. The only way to reconcile these readings, according to the text, is if the dust grains are something entirely different, not akin to sand or ice. These are described as large, remarkably complex particles, black and porous, resembling smoke. Such material is not naturally occurring dust. It is described as a manufactured substance. The chemical composition is anomalous. The physical properties are unexpected, presenting a perfectly coherent system of anomalies, as if its sole purpose is to induce self-doubt. Manufactured material. That is the precise phrase employed. We do have publicly accessible data concerning the polarization. A scientific paper was published in September, detailing optical observations gathered from multiple telescopes. The degree of polarization for 3I Atlas was measured at -2.1% at a phase angle of approximately 90 degrees. Negative polarization at this angle is exceptionally rare. It signifies that the light is polarized perpendicular to the scattering plane, a phenomenon observed only with particles possessing very specific characteristics, highly irregular shapes, and intricate internal structures. The paper noted this observation as unusual, but stopped short of declaring it impossible. This purported insider claims that internal discussions progressed further, with the measurements being so far outside established parameters that instrument error was initially assumed until repeated observations confirmed the findings. If the dust grains are indeed large, complex, and porous, this suggests a formation mechanism distinct from anything observed in conventional comets. Comets release dust when ice vaporizes and carries particles from their surface. This dust is typically small, on the order of micrometers, and composed of relatively simple silicate or carbonaceous materials. However, large porous particles indicate a different origin. It aligns more closely with the description of smoke, aerosol particles, finely dispersed material with a significant surface area to volume ratio. This type of dust is typically generated through combustion, industrial processes, or the breakdown of solid materials into ultrafine powders rather than the sublimation of ice from a rocky body. The text continues by addressing the object's rotation, or rather, the absence thereof. It reads, "We observe a feature that should not exist, a faint, smear-like tail pointing directly towards the sun. Allegedly, a powerful carbon dioxide jet is emanating from its sun-facing side, sufficiently strong to propel heavy water ice grains that sunlight cannot easily dislodge. This suggests a forceful, directional propulsion. However, The object is not rotating. We have observed it for extended periods, and its brightness remains constant, not fluctuating by even a fraction of a percent. It is a perfectly stable signal. A jet of such intensity emanating from a rotating body would produce a pulse, a flicker, a discernible rhythm. Instead, we observe absolute, unwavering stillness. The explanation for the tail necessitates a violent, directional event. The observation of its light requires a uniformly dispersed cloud. These two observations are contradictory. One must be inaccurate. Either the model describing the tail is flawed, or the cloud itself is not naturally occurring. This is a subtle but important point. If 3 Atlas were rotating and possessed a jet emanating from one side, we would expect periodic variations in brightness as the jet rotates into and out of view, and as different sections of the nucleus reflect sunlight towards us. This is standard behavior for comets, exhibiting fluctuating light curves. 3 Atlas, however, does not. According to this researcher, the brightness remains constant and stable, a flat line. This implies one of two possibilities. Either the object is not rotating at all, which is nearly impossible for a body traveling through space for billions of years, as every collision and gravitational interaction imparts angular momentum, or the brightness is constant because the outgassing is perfectly symmetrical and uniform, occurring equally in all directions at all times. However, a symmetrical outgassing pattern cannot account for the forward-pointing tail, which is directed towards the sun. This necessitates directionality, a jet, and asymmetry. Therefore, we have two conflicting observations: a tail that demands a jet, and a brightness curve that demands symmetry. Both cannot be simultaneously true unless the cloud of dust and gas surrounding the object is somehow decoupled from its rotation, or unless the object actively regulates its surface activity to maintain constant brightness irrespective of its orientation. Neither of these scenarios aligns with natural phenomena. Furthermore, there is the thermal issue. The text states, "Then there is the heat. The object is cold. It is absorbing gigawatts of raw solar energy, enough to power a small city. When we calculate the energy budget, there is a substantial surplus. This heat must dissipate somewhere. It should be causing enormous plumes of water vapor to be released. However, the water is not present. It's akin to directing a blowtorch at an ice cube and observing it fail to melt. The object has devised a method to either dispose of or regulate an immense thermal load, maintaining its surface at a specific low temperature. Energy balance. This is one of the most fundamental principles in physics. Energy input equals energy output plus or minus any stored energy. For a comet approaching the sun, the energy input is solar radiation. The energy output consists of thermal radiation and the latent heat of sublimation. As ice transforms into gas, it absorbs energy, which is how comets remain cool. The sublimation process acts as a heat sink. But if 3I Atlas is absorbing gigawatts of solar power and not releasing a proportional amount of water vapor, where is the energy going? According to this researcher, the thermal models do not balance. There is a surplus of heat that should be driving activity, but is not manifesting in the expected emissions. One possibility is that the surface is highly reflective. If a significant portion of the sunlight is reflected rather than absorbed, the energy input is reduced. However, in such a case, the object should appear brighter than it does. Another explanation is that the heat is being conducted into the interior and stored within the bulk mass. This would require exceptionally high thermal conductivity, which is unusual for icy materials. Alternatively, the heat might be radiated away in wavelengths we are not measuring, such as infrared or far infrared. Or the object is actively regulating its surface temperature, which may sound improbable, but the data appears to support this conclusion. Finally, let us consider the trajectory. The text states, and that is before even examining the path it took to reach this location. Its trajectory is a statistical anomaly. It follows a perfect low angular momentum orbit, the kind that ensures a close approach. Physicists who analyze such phenomena are direct. There is no known natural process that guides massive objects onto these specific trajectories. It was not merely a random encounter. For all practical purposes, this object was delivered from the darkness. We have already discussed the alignment with the ecliptic, the timing of its planetary encounter, and the associated probabilities. However, this adds another dimension: low angular momentum. This implies that the orbit is not only aligned with the planets, but also that the object is moving at a relatively slow speed compared to typical interstellar velocities. Most interstellar objects traverse the solar system at speeds of tens of kilometers per second. Oumuamua, for instance, was traveling at 26 kilometers per second relative to the Sun. 3I Atlas, however, is moving at approximately 60 kilometers per second in interstellar space. Yet, when accounting for the Sun's gravitational influence, its speed during close approach is reduced, making it manageable, almost as if it were designed to linger. The source concludes with a unifying statement: you fail to grasp it. None of these issues are isolated. They are all symptoms of a single underlying ailment. A jet powerful enough to create the tail would cause the object to flicker. It does not. A body of such immense mass should be inert. It is not. The sun's heat should be vaporizing it. It registers no significant effect. Each paradox presents a barrier, and we stand here, fixated on these barriers, refusing to perceive the shape of the room. This is not a failure of our models. It is a glimpse into the mechanisms operating beneath them. And these mechanisms are incorrect. A glimpse into the underlying machinery. That phrase is particularly striking because it suggests that the anomalies are not flaws, but intentional features, implying the object is not malfunctioning, but operating according to principles we do not yet comprehend. The researcher then proposes an explanation, one that borders on science fiction, but which, according to them, is the only physical model that renders the data consistent. Chapter 4: The Chemical Nightmare. Let us discuss the composition of the material actively emanating from this object, because its chemistry is not merely unusual. According to the leaked document, it is impossible. The nickel anomaly begins with temperature. When the Very Large Telescope's UV spectrograph was directed at 3 Atlas between August and September, it detected emission lines corresponding to nickel atoms. Not nickel compounds, but pure atomic nickel glowing within the spectrum, present at every observation epoch. Herein lies the problem. Nickel is a refractory metal, with a melting point of 1,455 degrees Celsius and a boiling point of 2,913 degrees Celsius. At the distance 3 Atlas was orbiting, between 3.1 and 2.1 astronomical units from the Sun, surface temperatures would range between -100 and -50 degrees Celsius, far below the point at which solid nickel could sublimate into atomic vapor. Yet, there it is, streaming off in measurable quantities. The official explanation presented in the published paper is cautious. It states, "The presence of nickel and iron atoms in a cometary coma is extremely puzzling. At the distances at which comets are typically observed, the temperature is far too low to vaporize silicate, sulfide, and metallic grains that contain nickel and iron atoms. They suggest a parent molecule, an organic compound containing nickel that decomposes upon exposure to sunlight, releasing nickel atoms. However, they do not identify this molecule because, in nature, nickel does not readily form many volatile compounds. It is chemically stable and tends to remain solid. The alleged insider goes further, identifying the molecule as nickel tetracarbonyl and explaining why this is deeply concerning. Nickel tetracarbonyl is classified by chemists as an organometallic compound consisting of one nickel atom bonded to 4 carbon monoxide molecules. It is a liquid at room temperature, highly volatile, boiling at 43 degrees Celsius, and crucially, it is photosensitive. Exposure to ultraviolet light, such as that emitted abundantly by the sun, causes it to decompose, releasing the carbon monoxide groups and leaving behind pure nickel atoms. This would perfectly account for the observations. Nickel tetracarbonyl on the surface, slightly warmed by sunlight, begins to sublimate. The vapor drifts into space. Ultraviolet photons then strike it, causing the molecule to break down. Atomic nickel appears in the spectrum. Because the decomposition is light-driven rather than solely heat-driven, the nickel production would be extremely sensitive to solar illumination. A minute change in distance or a slight shift in angle would dramatically alter the rate of production. This matches the data from the VLT, which shows the nickel production rate increasing sharply as 3I Atlas approaches the Sun, with the rate dependent on the 9th power of the distance, a steep and pronounced relationship, exactly as would be expected from a photodissociation process. So, the chemistry aligns. But here is the critical issue. Nickel tetracarbonyl does not occur in nature. It is synthetic, manufactured in industrial settings using the Mond process. Metallic nickel is exposed to carbon monoxide gas under high pressure and moderate temperature, leading to the formation of nickel tetracarbonyl. This compound is then heated in a separate chamber, causing it to decompose and yielding purified nickel. This refining technique was patented in 1890. How, then, does a synthetic industrial chemical end up on an interstellar comet? One possibility is that the conditions necessary for forming nickel tetracarbonyl exist somewhere in space. Protoplanetary disks are rich in carbon monoxide. If metallic nickel grains are present, and if the pressure and temperature are conducive, the compound might form naturally. This is not impossible, but it is unlikely. Furthermore, even if it were to form, nickel tetracarbonyl is unstable and decomposes over time, particularly when exposed to radiation. An object traveling through interstellar space for billions of years, bathed in cosmic rays, should not retain intact nickel tetracarbonyl on its surface unless it is being actively and continuously produced by some internal process. This is the hypothesis put forth by the insider, that 3 Atlas is not carrying ancient nickel tetracarbonyl from its formation, but is generating it as a byproduct of its internal processes. Then there is the matter of iron, or rather, its absence. In typical comets, nickel and iron are found together, present in ratios similar to their cosmic abundance, roughly 1 nickel atom for every 20 iron atoms, as observed in the Sun. This is what is expected from material that originated in a protoplanetary disk around a star. 3I Atlas exhibits a pronounced dominance of nickel. Iron was only detected in the spectrum when the object was closer than 2.64 astronomical units. Even then, the nickel-to-iron ratio remained significantly higher than normal by an order of magnitude. Why is this the case? If both metals are present in the comet's composition, why does nickel sublimate freely while iron remains bound? The insider's explanation links back to nickel tetracarbonyl. Iron does not form a comparably volatile compound. While iron pentacarbonyl exists, it is less stable, and less likely to form under the same conditions. If the outgassing process preferentially produces nickel tetracarbonyl, nickel would be observed without iron. The chemistry is selective. But again, this requires an active process, not merely ice sublimation carrying metallic grains along. It suggests something chemically sophisticated. Now, let us examine the dust, because the polarization data is where the anomalies become truly extraordinary. When light scatters off dust particles, the angle of polarization is dependent on the size, shape, and composition of those particles. Astronomers utilize this as a diagnostic tool. By measuring the polarization and comparing it to theoretical models, they can infer the type of dust present. Every comet and asteroid ever studied falls within a predictable range. Silicate dust, ice grains, and carbonaceous particles all produce similar polarization signatures, with only minor variations within established bounds. 3I Atlas, however, is off the charts. According to publicly available data, the polarization at a 90-degree phase angle is -2.1%. Negative polarization at this geometry is exceptionally rare and typically indicates particles with extremely irregular shapes or complex internal structures. The leaked text describes the reaction upon initial receipt of this data. Our director insisted we were messing up for the best part of a week until we repeated the result. They meticulously checked the instruments, recalibrated them, and performed further observations, yielding the same outcome. The only plausible explanation for these readings, according to the text, is that the dust grains are fundamentally different from natural dust, not the kind of particles formed when ice sublimates and carries rocky material from a comet's surface. The text describes them as large, incredibly complex particles, black and porous as smoke. Consider the implications of this description. Typical cometary dust consists of small particles, on the micrometer scale, a few micrometers in diameter, with simple grain structures. However, large, complex particles suggest something different. Aggregates, or fluffy structures with substantial internal voids, possessing a high surface area and low density, akin to soot or aerosols. This is the type of dust generated through combustion or chemical vapor deposition processes, where particles are built atom by atom, layer by layer, creating intricate structures, rather than through natural processes occurring on a frozen celestial body. Furthermore, the description black is significant. Most cometary dust is relatively bright, reflecting a considerable amount of sunlight, which contributes to their visibility. Conversely, black dust absorbs light. It possesses excellent thermal efficiency and heats up rapidly. If the particulate matter surrounding 3I 2019 Q4 Atlas were black and porous, it would readily absorb solar radiation, warm up, and subsequently emit infrared energy. This brings us back to the fundamental thermal enigma. Where is all that absorbed energy dissipating? The internal report frames the chemical peculiarities as part of a broader pattern. In its words, the chemistry is incorrect. The physics is incorrect. It's a perfectly self-consistent system of incorrectness, as though its entire purpose is to make us question our own understanding. Self-consistent is the operative phrase. While each individual anomaly might be dismissed as unusual but plausible, their collective presence forms a cohesive picture, albeit one that deviates from the expected characteristics of a natural comet. It's akin to examining a complex mechanism where every component exhibits slight deviations from its specifications, yet the entire apparatus still functions. This leads one to ponder whether the specifications themselves are flawed or if the machine was engineered according to a different set of principles. Now, I wish to state clearly, the prevailing scientific consensus shared by the majority of astronomers, is that 3I 2019 Q4 Atlas is indeed a comet. It is acknowledged as an unusual comet, possessing properties that stretch the limits of our prior observations, but it remains a natural phenomenon, explicable within the established framework of planetary science. NASA has explicitly articulated this stance. Tom Statler, NASA's lead scientist for small bodies in the solar system, informed reporters, "It looks like a comet. It behaves like a comet. In nearly every regard, it strongly resembles the comets we are familiar with." And he is not incorrect. 3I 2019 Q4 Atlas exhibits a coma, possesses a tail, and is outgassing as it approaches the sun. These are indeed characteristic cometary behaviors. However, the nuances, specifically the chemical composition, the nature of the dust, and the thermal equilibrium, are where the perplexing questions arise. The leaked internal document does not assert definitive conclusions. It does not declare the object to be definitively alien or artificial. Its assertion is simpler, and in some respects, more unsettling. Celestial body. Failed. Not. We are still investigating. Not. We require additional data. Failed. That was the term they employed. And if this leak is authentic, if it accurately reflects the discussions occurring within the European Space Agency's working group, then there are scientists examining this data who are privately admitting their lack of answers. This, in turn, prompts a crucial question. If conventional explanations prove inadequate, what alternatives remain? This is where the report shifts into territory that, depending on one's disposition, might be characterized as theoretical physics or science fiction. Chapter 5. The rotation that vanishes. Every celestial object in the cosmos experiences rotation. It is an inescapable phenomenon. Collisions impart spin, and gravitational interactions contribute to angular momentum. Even the most subtle cosmic encounter, occurring billions of years ago, results in an object tumbling through the void. Rotation is the default state. Consequently, when astronomers observe a new comet or asteroid, one of their initial investigative steps is to ascertain its rotation period, its spin rate. They meticulously monitor its brightness over time. As the object rotates, different facets of its surface become oriented towards the observer. Variations in surface albedo, dark patches, bright patches, irregular shapes, cause fluctuations in luminosity, sometimes subtle, sometimes pronounced, but always present. This is termed a light curve. When brightness is plotted against time, a periodic waveform emerges. The period indicates the rate of rotation, while the amplitude reveals the degree of surface irregularity. This is among the most fundamental measurements in observational astronomy. 3I 2019 Q4 Atlas lacks this characteristic. According to the leaked report, the object has been under continuous observation. The Hubble Space Telescope has scrutinized it. The James Webb Space Telescope has observed it, and ground-based observatories have tracked it night after night, yet its brightness remains constant. The report states, "We have stared at it for years, and it is a dead flat line, utterly flat. No variation, not a flicker, no periodic signal whatsoever." This is not merely unusual, it is fundamentally incorrect. Even a perfectly spherical object, if possessing surface features, will exhibit brightness variations as it rotates due to differing albedos on its surface. And comets are never perfectly spherical. They are irregular, lumpy, and cratered. Outgassing jets produce bright areas, while accumulated dust can create dark patches. Rotation should manifest as a discernible rhythm, yet 3I 2019 Q4 Atlas remains steadfastly unwavering. It is true that a scenario exists where rotation might not be readily apparent. If the object is rotating extremely slowly With a period measured in weeks or months, a complete cycle might not be detectable within limited observation windows. However, even in such cases, one would anticipate observing gradual shifts in brightness as the object slowly turns. A drift, a discernible trend, something. The report describes the object's brightness as unwavering, stable, and fixed. This implies one of two possibilities. Either 3I 2019 Q4, Atlas, is not rotating at all, a physically implausible scenario for an object in space for years, or it is rotating, but its brightness is somehow decoupled from this rotation, which necessitates an explanation. Herein lies the complexity. Both the Hubble and Webb telescopes have documented a distinct feature: a forward-facing tail, a plume of material extending towards the sun. The conventional explanation for such a phenomenon is a jet, a localized outgassing event originating from the sunward side of the comet where solar heating is most intense. Jets are a common occurrence on comets. Sublimating ice generates pressure, and gas escapes through fissures or vents, carrying dust along to form a directional plume. However, jets are inherently asymmetrical. They emanate from a specific point and extend in a particular direction. If the object is rotating, this jet would move with it, at times pointing towards us, at others away, or sideways. The amount of reflected sunlight would fluctuate, resulting in a pulse, a flicker, a brightness variation synchronized with the rotation period. 3I 2019 Q4, Atlas, presents a feature resembling a jet, yet it shows no corresponding brightness variation. These two observations are contradictory. The internal report articulates this conflict starkly. A jet powerful enough to create the tail would cause the object to flicker. It does not. The explanation for the tail necessitates a vigorous, directional event, while the observation of its light output demands a quiescent, uniform state. Let us dissect this. If the tail is indeed a genuine manifestation of a jet, then this jet should be observable as a periodic fluctuation in brightness. Yet, the brightness remains constant. This leads to two possibilities. Either the tail is not a jet but something else entirely, or the brightness is somehow independent of the jet's activity. One potential explanation is that the outgassing is isotropic, perfectly uniform in all directions, akin to a sphere slowly evaporating over time. In this scenario, there would be no distinct jets, no asymmetry. This would account for the constant brightness, but fails to explain the forward-pointing tail. Isotropic outgassing produces a symmetrical coma and a tail pushed backward by the solar wind, not a plume directed forward. Another possibility is that the dust cloud surrounding the object is so dense and optically opaque that it effectively masks any fluctuations in brightness. The jet might be active, but it is concealed within a shroud of dust. What we perceive is the outer envelope, which appears uniform. This could be a plausible explanation, but it requires an extraordinarily high rate of dust production. However, spectroscopic data indicates that the coma is relatively tenuous, not optically thick. A third hypothesis suggests that the object actively regulates its own brightness, somehow maintaining a consistently reflective surface, irrespective of rotation or jet activity. This may sound far-fetched, but it is the only scenario that reconciles both observations without dismissing one as erroneous. The internal report posits that this points to something more profound, that the issue of rotation is not an isolated problem, but an integral part of the same systemic anomalies. It suggests the same underlying mechanism responsible for the recoilless outgassing, the synthetic chemistry, and the shedding of manufactured dust. Furthermore, this mechanism, according to the report, is internal, not powered by the sun, and not driven by external heating. This leads us to the subsequent piece of the puzzle, the thermal ghost. 3I 2019 Q4, Atlas, is absorbing gigawatts of solar energy. This is not an estimation. It is a calculable value. One multiplies the object's cross-sectional area by the solar flux at its orbital distance to determine the power input. For an object approximately 5 kilometers in diameter, situated at roughly 2 astronomical units from the Sun, the absorbed power is on the order of several gigawatts, sufficient to power a small city. This energy must be dissipated somewhere. In a typical comet, this energy is utilized to sublimate ice, water ice, carbon dioxide ice, and other volatile compounds. The phase transition from solid to gas absorbs a substantial amount of energy. This is how comets maintain their low temperatures. The sublimation process acts as a heat sink, with energy input resulting in gas output. However, herein lies the conundrum. The quantity of energy being absorbed does not correlate with the amount of material being released. According to the leaked internal report, the thermal models do not achieve balance. It states, "We calculate the energy budget, and there is a massive surplus. That heat must go somewhere. It should be driving off enormous plumes of water vapor, but the water is not present." The James Webb Space Telescope measured the gas composition, revealing primarily carbon dioxide, with some carbon monoxide. Water is present, but in quantities significantly lower than anticipated. The ratio of carbon dioxide to water is 8:1, which is exceptionally high. Most comets are water-dominated. Water is the principal volatile driving cometary activity. But if 3I 2019 Q4, Atlas, is absorbing gigawatts of energy and not releasing a commensurate amount of water, where is that energy going? One possibility is that it is being radiated away. All objects emit thermal radiation. The hotter they are, the more they radiate. If 3I 2019 Q4, Atlas, possesses a high emissivity, meaning its surface is efficient at radiating heat, it could dissipate energy into space without needing to sublimate substantial quantities of ice. However, this presents a problem. Spectroscopic data suggests the surface temperature is remarkably cold, far colder than would be expected for an object absorbing such a significant amount of sunlight. The report notes, "The thing is cold. It's like pointing a blowtorch at an ice cube and watching it refuse to melt. Therefore, the object is absorbing gigawatts of energy, not releasing water, and yet it remains cold. That energy is vanishing. Into what? Into where?" The report suggests that the object has devised a method to regulate its thermal load. It states, "The object has found a way to either dispose of or regulate an enormous thermal load to maintain its temperature." The word regulate again implies control, a system rather than passive thermal physics. It suggests active management. If the surface temperature is being maintained artificially low, this necessitates either an exceptionally efficient cooling mechanism or an internal heat sink, something that absorbs and stores or transforms energy without elevating the surface temperature. What in nature could accomplish this? Very little, and certainly not on a comet. The internal assessment concludes, "The gigawatts from the Sun are a trivial external variable to a monstrous 3 billion-year-old object with its own power source. It radiates solar energy away passively, like any inert rock would, because the Sun is not part of its life cycle. Its own power source, an internal engine, something generating energy from within, independent of solar heating. And if this premise holds true, then the thermal regulation ceases to be a mystery. It becomes a consequence. The object does not require the Sun. It is indifferent to it. This leads to the most profoundly unsettling question of all. If 3I 2019 Q4, Atlas, possesses an internal power source, what is it?" Chapter 6. The cue ball hypothesis. At this juncture, the leaked report ventures into physics that sounds like science fiction. However, according to the researcher, it represents the sole framework that renders the observed data coherent. The report states, it is a macroscopic quantum object, a stable, massive particle left over from the first microseconds of the Big Bang, a bubble of a different set of physical laws that has managed to survive, cloaked in a skin of our reality. The designation for this engine within theoretical physics is a non-topological soliton. This is not a mere hypothesis. It is the only known physical construct that aligns with the presented data. A cue ball. Let us delve into its implications. In the nascent universe, immediately following the Big Bang, conditions were extreme, characterized by temperatures and densities far exceeding anything we can replicate. Under such energies, the fundamental forces behaved differently. Particles that are distinct today, electrons, quarks, photons, were unified within a superheated plasma. As the universe expanded and cooled, it underwent phase transitions. Symmetries were broken, forces separated, and matter coalesced into the forms we recognize. However, phase transitions do not always occur uniformly. Just as freezing water can create pockets and bubbles within ice, the early universe might have generated defects, regions where the phase transition did not conclude cleanly. These were pockets where the old, unified state persisted, trapped and stable. Such defects have been given names: cosmic strings, monopoles, domain walls, and cue balls. A cue ball is a non-topological soliton. This is specialized terminology, so allow me to translate. A soliton is a self-sustaining wave, a localized concentration of energy that maintains its form due to a delicate balance between dispersive forces attempting to spread it out and nonlinear effects drawing it back together. Non-topological signifies that it is not held together by the geometric structure of spacetime, akin to a knot. Instead, it is stabilized by a conserved quantity, a charge. The Q in cue ball refers to this charge. In certain theoretical models, particularly those involving supersymmetric extensions of the Standard Model, cue balls can form. They are composed of scalar fields, which are fields possessing zero spin. These fields have potential energy, and under specific configurations, they can coalesce to form a stable, massive object, a bubble wherein the field inside possesses a different value than that outside. The bubble does not collapse because this particular field configuration is energetically favorable. It represents a local minimum within the potential energy landscape. The crucial attribute of a cue ball is that it is its own energy source. The field within is decaying extremely slowly, releasing energy over billions of years. This energy manifests as particles, radiation, and heat. The cue ball gradually loses mass, but this decay process is so protracted that a cue ball formed in the early universe could conceivably still exist today. Now, this remains speculative physics. Cue balls have never been directly observed. They are predicted by certain theories, but these theories themselves have not been empirically confirmed. The majority of physicists consider them intriguing theoretical constructs, objects that might exist in the universe, but likely do not. Yet, the internal report asserts that 3I 2019 Q4, Atlas, perfectly matches this description. Let us trace the logical progression. If 3I 2019 Q4, Atlas, is a cue ball, what would we anticipate observing? Firstly, immense mass concentrated within a small volume. Cue balls are exceptionally dense, with the field concentrated internally. A cue ball approximately 3 kilometers in diameter could readily possess the mass of a small moon, equivalent to 33 billion tons. This aligns with the minimum mass estimate derived from the absence of non-gravitational acceleration. Secondly, isotropic outgassing. The decay of the cue ball occurs internally, at its core. Energy is released uniformly in all directions. This internal energy heats the surrounding material, a mantle of accumulated ice and dust, from the inside out. This ice then sublimes symmetrically, producing no directional thrust or jets. The outgassing is perfectly balanced, resulting in no net recoil. This resolves the paradox of a violent outgassing event with no discernible consequence. The internal decay engine generates the gas, which then escapes equally in all directions. Newton's third law is satisfied, as action and reaction perfectly cancel each other out. Thirdly, constant brightness. If the outgassing is isotropic, the cloud of dust and gas surrounding the cue ball will be spherically symmetrical. Its rotation becomes irrelevant. The object will appear identical from any vantage point. The brightness will not fluctuate because there is no asymmetry to rotate into and out of view. Fourthly, exotic chemistry. The decay process of a cue ball does not adhere to conventional thermodynamics. It is a particle physics phenomenon, operating at high energies and capable of generating unusual chemical compounds. The slow burn reactor, as the report terms it, operates at a constant low temperature, but it is not a thermal furnace. It is a quantum decay event. Over billions of years, this process yields byproducts: complex molecules, metallic carbonyls, manufactured dust, the exhaust of an ancient engine. Fifthly, thermal indifference. The cue ball is unconcerned with the sun's influence. Its internal energy source vastly overshadows solar heating. The surface temperature is regulated not by absorbing and re-radiating sunlight, but by the steady energy output from its core. The gigawatts of power from the sun are, in the report's words, a trivial external variable. Sixthly, the trajectory. If cue balls are commonplace, if they constitute a component of dark matter, then the galaxy is teeming with them. They are not rare, they are ubiquitous. 3I 2019 Q4, Atlas, is not debris ejected from a distant star. It is a fundamental constituent of the cosmic population, a relic from the Big Bang. This explains why such a massive object was detected so rapidly. We are not observing planetary ejecta. We are witnessing dark matter itself. The report frames this as a revelation. The cue ball is the mass. Its engine is its own decay. The lack of recoil is no longer a paradox. It is a defining feature. The outgassing isn't a jet. It is an isotropic ablation, a perfectly spherically symmetric outflow of matter. As the core's energy boils its mantle from the inside out, there is no net thrust. It moves without consequence because the event is occurring within a perfectly balanced system. And then it concludes, "This is not a matter of belief. This is the only known physics that makes the data coherent. Once you look at it, the entire system of wrongness snaps into a logical, horrifying picture." Horrifying. That is the word employed, not intriguing or surprising. Horrifying. Why? Because if 3I 2019 Q4, Atlas, is a cue ball, then dark matter is not merely invisible, inert matter scattered throughout space. It is active, massive, and pervasive. The galaxy is not sparsely populated with a few interstellar rocks. It is swarming with ancient, massive objects, each a relic from the Big Bang, each slowly decaying, each capable of entering a solar system and doing what, precisely? Nothing, or something far worse. But here is the critical point. The cue ball hypothesis is testable. The report concludes with specific, falsifiable predictions. Screen cap this. First prediction: activity independent of solar distance. The behavior of a normal comet is intrinsically linked to solar heating. As it recedes from the sun, its activity diminishes, outgassing slows, and brightness fades. This pattern is universal. Every comet we have observed adheres to it. However, if 3I 2019 Q4, Atlas, possesses an internal engine, its activity will not follow this pattern. As it moves into the outer solar system, beyond 3 astronomical units, beyond 4, its brightness and mass loss rate should remain impossibly high. It will defy the thermodynamic expectations for a passive cooling body. This is verifiable. We can observe this. When the object re-emerges in December, after passing behind the sun, we will have months to observe it as it moves outward. If it remains bright, if the outgassing continues unabated, that will be definitive proof. Comets do not behave in this manner. Second prediction: high energy emission. The decay of a cue ball is a particle physics event, estimated by the report to release 73 megawatts of energy. This energy does not simply vanish. It generates particles, high-energy particles, including gamma rays and X-rays, a non-thermal, high-energy signature that should be detectable. The report states, point a gamma-ray telescope at it. If you detect a signal that is not attributable to solar-wind interaction, you're not seeing a comet. You're hearing the heartbeat of an object that doesn't follow the rules of physics. This, too, is testable. Gamma-ray observatories exist. Fermi Gamma-ray Space Telescope, for instance. If a high-energy source is detected at the location of 3I 2019 Q4, Atlas, we can confirm it. No comet emits gamma rays from internal processes. Only extreme astrophysical objects do. Pulsars, black holes, supernova remnants, or, if this hypothesis is correct, cue balls. Now, let me be absolutely explicit. This is not mainstream science. Cue balls are theoretical and speculative. Most astrophysicists would likely dismiss this hypothesis outright. It is an exotic concept that requires accepting that dark matter exists in a form we have never detected, that the early universe produced stable, macroscopic quantum objects, and that one of these objects happens to be traversing our solar system at this very moment. The simpler explanation is that 3I 2019 Q4 Atlas is merely an unusual comet exhibiting peculiar chemistry, unique dust composition, perhaps a binary nucleus, or some internal structure we have yet to fully comprehend, but still a natural phenomenon, still explicable within conventional planetary science. A significant portion of the scientific community currently holds a specific viewpoint, and it's entirely plausible they are correct. However, if the recently disclosed correspondence is authentic, and if a working group within the European Space Agency is indeed grappling with reconciling the observed data, then the possibility of a dense, spherical object, often referred to as a CQ ball, is being considered discreetly. This is not being presented as a definitive answer, but rather as the sole viable explanation that doesn't necessitate disregarding half of the gathered evidence. Furthermore, should the current projections prove accurate, specifically if the object designated 3I Atlas remains luminous as it recedes, and if gamma rays are detected, then the prevailing discussion is poised for a rapid transformation. Chapter 7: The Obscured Maneuver Period. In 26 days from now, 3I Atlas is scheduled to perform an action that ought to cause considerable unease. It will become undetectable. This isn't to say the object will cease to exist or deviate from its celestial path. Rather, from our vantage point on Earth, it will be rendered invisible, concealed behind the sun, and overwhelmed by the brilliant glare of our star. This event is slated for October 24th, when the object reaches solar conjunction. At this point, Earth, the Sun, and 3I Atlas will form a perfect alignment, with the Sun situated directly between Earth and the object. From this juncture until early December, our ability to observe it, track its trajectory, or measure its luminescence or spectral signature will be entirely compromised. For a duration of nearly 6 weeks, the celestial body will effectively vanish from our sight. Intriguingly, on October 29th, precisely amidst this period of obscured observation, 3I Atlas will achieve its perihelion, its closest point of approach to the Sun. This occurs at a distance of 1.4 astronomical units, situated just inside the orbital path of Mars. This is the very moment when solar radiation is most intense, when a typical comet would exhibit its peak activity, and when outgassing would be at its highest. Yet, we will be incapable of witnessing any of this activity. This precise timing has not escaped notice. Avi Loeb himself highlighted this in his article published on October 3rd. He stated, "At its perihelion on October 29th, 2025, when it reaches 1.35 astronomical units from the Sun, 3I Atlas will be completely hidden from Earth by the Sun. Assuming this obscuration occurs within a solar elongation of 30 degrees, it is straightforward to calculate the probability of this alignment with the Sun and Earth as approximately 7%. 7% is not an insignificant chance, nor is it a random occurrence. It represents a 1 in 14 probability. This is where the situation becomes particularly unsettling. If 3I Atlas were indeed a spacecraft equipped with propulsion capabilities, allowing for orbital adjustments, its perihelion would represent the ideal juncture for such a maneuver. Specifically, it would be the optimal time to execute what is known as a reverse Orth maneuver. Allow me to elaborate. The Orth effect, in the realm of orbital mechanics, is a principle where the change in kinetic energy achieved by firing a rocket engine is contingent not solely on the magnitude of the thrust, but also on the craft's current velocity. Engaging the engines when moving at high speed yields a greater return on investment. The increase in kinetic energy is amplified. Spacecraft routinely leverage this phenomenon. When the objective is to escape the gravitational pull of a planet or star, thrust is applied at periapsis, the point of closest approach, where orbital velocity is at its maximum. This constitutes a standard Orth maneuver, maximizing efficiency. A reverse Orth maneuver is the inverse. Imagine a craft moving at high velocity along a hyperbolic trajectory, intending to depart the solar system. However, the objective is to remain within the system and achieve gravitational capture. In such a scenario, engines would be fired at perihelion when velocity is at its peak to effect deceleration. The reduction in velocity is most efficient at this point. Energy is dissipated, causing the trajectory to shift from hyperbolic to elliptical. Instead of escaping, the object becomes bound to the central body. Therefore, if 3I Atlas were intended to remain within the solar system, October 29th would be the opportune moment for braking, and this action would occur concealed behind the Sun, rendering it unobservable from Earth. Loeb frames this observation with considerable care. He is not asserting that this will happen, but rather drawing attention to the advantageous geometry of the situation. He writes in his article, "This could be deliberate to avoid detailed observations from Earth-based telescopes when the object is at its brightest, or when devices are dispatched from that hidden vantage point towards Earth. The most suitable point for a reverse solar Orth maneuver to achieve solar orbit is at perihelion. It is this optimal breaking point for 3I Atlas that is obscured from our view by the Sun." He uses the term devices, referring to small probes that might be released from the primary object, capitalizing on its retrograde orbit and close planetary encounters to reach Mars, Venus, or Jupiter with minimal propellant expenditure. The calculations for such a scenario already exist. In Loeb's July publication, co-authored with Adam Hibbert and Adam Cry, they meticulously detailed the delta V requirements. Delta V signifies the change in velocity necessary to reach a specific target. For 3I Atlas to dispatch a probe to Mars in early October, the required delta V is less than 5 kilometers per second. This is comparable to the capabilities of an intercontinental ballistic missile, achievable with conventional chemical propulsion. The situation for Venus is similar, with a required delta V of less than 5 kilometers per second until July. For Jupiter, the requirement remains below 5 kilometers per second through November. Earth, however, necessitates a greater velocity change, consistently exceeding 5 kilometers per second, indicating a higher energy expenditure. This might explain why, in the context of a reconnaissance mission, Earth could be bypassed during the initial phase, allowing for data collection from other planets before a decision is made regarding the feasibility and desirability of a mission to Earth. Again, this remains hypothetical. Loeb is not claiming this is occurring, but rather highlighting that the trajectory and timing offer this possibility. The crucial element, however, is that we will not have definitive answers until December. When 3I Atlas emerges from behind the Sun in early December, it will appear in the pre-dawn sky, low on the eastern horizon. Though faint, it will be observable, and the immediate action of astronomers will be to ascertain its precise position, calculate its trajectory, and verify if any alterations have transpired. If the orbit remains identical to the predictions, and if the object is precisely where a purely gravitational path would dictate, then nothing extraordinary has occurred. It has simply passed its perihelion, outgassed, and continued on its outward trajectory, an unusual yet natural comet. Conversely, if the orbit has undergone a modification, even a slight deviation, it would indicate that something significant happened while it was hidden behind the Sun. This could involve a deliberate maneuver by the object, fragmentation, or some other event that altered its path, any of which would be profoundly significant. Loeb has identified a specific window for potential detection, November 21st to December 5th. He noted in an earlier blog post, the authors emphasize that their theory is falsifiable. Should 3I Atlas traverse the solar system without executing any unexpected maneuvers, particularly between November 21st and December 5th, 2025, the hypothesis would likely be disproven. A 2-week period constitutes the critical observation window. If any maneuvers were executed at perihelion, their effects would become detectable as deviations in the trajectory by late November. Astronomers will undoubtedly be vigilant. However, there exists another intriguing layer to this narrative, the precursor probe theory. In September, Loeb published an additional calculation. This theory posits that if 3I Atlas released a smaller object, essentially a probe, sometime prior to the present, and if this probe was traveling approximately 30 million kilometers ahead of the main body, it could have intercepted Mars during the current week, October 3rd, coinciding with the Mars flyby. The mathematical underpinnings of this scenario are sound. A probe does not require substantial dimensions. It could be merely a few meters across, perhaps 10 meters in diameter, roughly the size of a car. At this scale, reflecting sunlight at Martian distances, it would be imperceptible to Earth-based telescopes. While we might not be able to detect it directly, its presence is theoretically possible. The high-resolution camera aboard the Mars Reconnaissance Orbiter is not solely focused on detecting the primary object. According to Loeb's suggestion, it should also be actively scanning the object's approach corridor, specifically looking for smaller, preceding objects, essentially scouts. Has NASA implemented such a surveillance strategy? We are not privy to this information. The detailed imaging plans have not been publicly disclosed. Nevertheless, the possibility remains. And should any anomaly be detected within the data, something small and unanticipated, the discourse surrounding the object would instantly shift. The more probable scenario, the one anticipated by the majority of scientists, is that no unusual activity will transpire. 3I Atlas will complete its perihelion passage, continue its outward journey, and gradually fade from view. It will be recognized as an intriguing, albeit peculiar comet, a noteworthy interstellar visitor, but ultimately a natural celestial phenomenon. There will be no maneuvers, no probes, and no deviations. This is the baseline expectation, and it is likely the accurate one. Yet, the celestial geometry is unsettling. The timing of events is disquieting. The fact that the most pivotal moment of its close approach occurs when it is beyond our observational capabilities is deeply concerning. And if we were to incorporate the CQ ball hypothesis into this complex equation, the situation becomes even more troubling. This is because a CQ ball, by its nature, does not require propulsion. It does not maneuver. It is an inert object. However, it possesses immense mass, estimated at 33 billion tons. If such an object passes in close proximity to a planet, it exerts a measurable gravitational influence. A planet's orbit could shift, albeit minutely, but detectably over time. Mars is of particular concern in this regard. 3I Atlas is scheduled to pass within 29 million kilometers of Mars today, a relatively close approach. While not a risk of collision, it is sufficiently near for gravitational interactions to become significant. If the object's mass truly aligns with the current estimates, Mars should experience a subtle gravitational pull. Its orbital elements, the precise parameters defining its path around the Sun, could be altered by a detectable margin. Astronomers meticulously monitor Mars, and its position is known with exceptional accuracy. Should 3I Atlas impart even a minor gravitational perturbation, this effect will be observed. It may not be immediately apparent, but as Mars continues its orbital journey over weeks and months, the deviation will accumulate. This presents another potential test, another avenue for either confirming or refuting the mass estimates of the object. The results of this observation are expected to become available over the ensuing months. Therefore, we must wait. October will pass, the object will be concealed, November will arrive, observations will recommence, and by December, we will have clearer insights. Did it maneuver? Did its trajectory change? Is the estimated mass accurate? The answers are forthcoming, regardless of our readiness to receive them. Chapter 8. The Decoy Scenario. Within the overarching theory, a more speculative sub-theory exists, potentially the most disquieting one yet. It proposes that 3I Atlas might serve as a diversion. This concept originated with Omar Ladiardi, a collaborator of Avi Loeb. He theorized that an advanced civilization might employ a natural-appearing interstellar comet as a decoy, something luminous, conspicuous, and captivating enough to draw the attention of telescopes and scientific scrutiny. This would allow the primary operation to unfold elsewhere, unobserved. Loeb discussed this possibility in an August blog post, stating, "My colleague Omar Ladiardi suggested that extraterrestrials might utilize a natural interstellar comet as a diversion to capture our attention while they conduct another operation in a different location near Earth. From this perspective, it would be fascinating to investigate whether there has been an increase in unidentified anomalous phenomena in Earth's atmosphere following the closest approach of 3I Atlas to the Sun on October 31st, 2025. An increased prevalence of UAP activity around the time 3I Atlas reaches perihelion is a testable hypothesis, and indeed, it is being tested. The Galileo Project, an initiative spearheaded by Loeb, is an astronomical research program dedicated to seeking evidence of extraterrestrial technology, not through radio signals or the observation of distant exoplanets, but in our immediate vicinity. It employs telescopes and sensors to monitor the sky for anomalous objects. The project operates 3 observatories, one at Harvard College Observatory in Massachusetts, another in Pennsylvania, and a third in Nevada. Each facility is outfitted with cameras, infrared sensors, radar, and audio detection equipment. These observatories continuously scan the entire celestial sphere, meticulously recording every moving object overhead. The system utilizes artificial intelligence to categorize these objects, identifying mundane items such as birds, aircraft, satellites, drones, and meteors. While the vast majority of these objects are readily explainable, occasionally an anomaly emerges, an object exhibiting movement patterns that defy conventional explanations, such as excessive speed, unusual deceleration, or abrupt changes in direction, inconsistent with the capabilities of conventional aircraft. These anomalies are flagged, subjected to detailed analysis, and thoroughly investigated. The Galileo project has been operational since late 2022 and has already amassed data on over 500,000 aerial objects. The overwhelming majority of these have been identified and explained, revealing no unusual characteristics. However, the system remains in place, diligently observing. According to Loeb, it will be maintaining heightened surveillance throughout October and November. He stated, "Fortunately, under my leadership, the Galileo Project will be monitoring the sky with its 3 observatories in Massachusetts, Pennsylvania, and Nevada during this critical period. Therefore, if UAP activity escalates, and if unusual phenomena begin to manifest in Earth's atmosphere while 3I Atlas is obscured by the Sun, the Galileo Project should be able to detect it. Any correlation, any alignment in timing would be of considerable interest." To be clear, Loeb is not predicting the appearance of alien spacecraft, nor is he definitively asserting that 3I Atlas is a decoy. He is suggesting that if it were, we should anticipate observing secondary activity, and his team is strategically positioned to conduct such observations. The decoy hypothesis rests on several underlying assumptions. Firstly, that 3I Atlas is either artificial in origin or under intelligent control. Secondly, that its objective is not direct contact, but rather reconnaissance. And thirdly, that the entity responsible for its creation or operation desires to divert humanity's attention, focusing it on the large, conspicuous object, while more discreet, stealthy operations are conducted closer to Earth. Why might an advanced civilization adopt such a strategy? One compelling reason is the principle of information symmetry. When scouting a species that may be hostile or unpredictable, direct self-disclosure is not advantageous. Instead, data is gathered discreetly, small probes are deployed with minimal observability, and assurance is sought that the target's attention is occupied elsewhere. 3I Atlas is inherently conspicuous, bright, unusual, and the subject of intense scrutiny from virtually every major telescope on Earth and in orbit. Scientific papers are being written, researchers are engaged in debate, and the media portrays it as a spectacular event. While global attention is directed towards this comet, the question arises, what activities might be occurring within our atmosphere or in Earth's orbit, involving smaller, quieter objects that are eluding our notice. The data collected by the Galileo project may provide answers, or at the very least, indicate whether there has been an uptick, a statistical anomaly, revealing an increased number of unexplained objects compared to the norm, particularly in the late October to early November timeframe. If such an increase is observed, it would not serve as definitive proof of the decoy hypothesis, as correlation does not equate to causation. However, it would be exceedingly difficult to disregard. There exists another perspective, the stealth hybrid spacecraft theory, proposed by Gabor, a reader of Loeb's work. This concept suggests that advanced civilizations might not construct spacecraft from raw materials. Instead, they could repurpose natural celestial bodies like asteroids and comets, terraforming them, hollowing them out, installing internal machinery, and utilizing their natural exterior as a form of camouflage. Loeb quoted so in his blog, stating, "Humanity is already planning asteroid mining missions, and for a more advanced civilization, this could represent a straightforward methodology. An asteroid hull provides exceptional natural shielding. The object itself offers inherent stealth. As long as there are no active emissions or artificial reflective surfaces, it would appear externally as a natural asteroid. This effectively resolves a significant challenge. If one intends to transmit an object to another star system, shielding becomes paramount. Cosmic rays, high-energy particles, and micrometeorites all pose threats. Interstellar space is inherently hostile. Constructing thick protective walls is an expensive and heavy endeavor. However, by commencing with a celestial rock, the shielding is intrinsically integrated. One then excavates the interior, installs the necessary systems, and embarks on the journey. From an external perspective, it would resemble a comet, exhibiting outgassing and a coma, behaving in a manner consistent with natural phenomena. Internally, however, it would house machinery, instruments, power sources, and perhaps even dormant crew members awaiting activation. This is not an entirely novel concept. Science fiction has explored this idea for decades, as seen in Arthur C. Clarke's Rendezvous with Rama, a colossal cylindrical spacecraft disguised as an asteroid, and Greg Bear's Forge of God, which features self-replicating machines concealed within comets. While the concept is familiar, its practical implications are significant. For journeys spanning interstellar distances, potentially lasting millennia in transit, the utilization of natural materials is a logical and efficient approach. Furthermore, it greatly complicates detection, as astronomers inherently classify rocky bodies as natural unless they exhibit overtly artificial characteristics. 3I Atlas has not displayed any unequivocally artificial attributes. There have been no radio transmissions, no detectable course corrections, and no artificial illumination. While its precise composition and physical properties do not perfectly align with our understanding of natural comets, and its trajectory raises suspicions, none of these factors constitute definitive proof. This ambiguity is the very essence of a stealth hybrid design. It offers deniability and remains inherently ambiguous. Proving its artificial nature would require extremely close proximity. By the time a mission could be launched to intercept such an object, it would likely have already departed. Consequently, we are left with a multitude of questions. Will the Galileo project detect any unusual phenomena in the coming weeks? Will there be an increase in UAP reports? Will objects appear that defy conventional classification? And if so, will these observations be linked to 3I Atlas? Or will October and November pass uneventfully, with no anomalies, no surge in activity, merely a comet disappearing behind the sun and reappearing on the other side. A strange, but ultimately natural occurrence. The data will ultimately provide the answers, regardless of our preparedness. We simply need to exercise patience for a few more weeks. Chapter 9. The Silence Protocol. The scientific community is experiencing a significant division regarding this particular celestial object. This schism is not manifesting openly through public press conferences or official declarations, but rather within more private spheres. Email correspondence, informal discussions in conference hallways, and late-night laboratory conversations. Two distinct factions have emerged, and the chasm between them is steadily widening. One group maintains that 3I Atlas is, in essence, a comet. They acknowledge its unusual characteristics and its potential to push the boundaries of our current understanding, but they firmly believe it remains within the purview of natural phenomena. They propose that its unusual chemistry can be explained by the presence of exotic parent molecules that have yet to be identified, and that the mass estimates might be imprecise. They contend that more refined data will ultimately clarify these discrepancies, and that patient, rigorous scientific inquiry will resolve the anomalies. The other faction expresses a greater degree of uncertainty. They are privy to the same data and conduct the same calculations as their colleagues. However, their findings are yielding results that do not align with established principles. These discrepancies are not confined to the fringes of the data. They are fundamental. The physics involved appears to defy conventional understanding unless one accepts premises that seem almost impossible. Extraordinary density, inherent internal energy sources, and synthetic chemical processes. The recently leaked correspondence from 4chan alludes to this internal division, stating, "The official stance is that 3I Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership regarding the cognitive dissonance this necessitates is becoming a significant professional concern for an increasing number of us." The term cognitive dissonance is particularly potent, signifying the simultaneous holding of two contradictory beliefs. In this context, it refers to the belief that the data is accurate while simultaneously maintaining that the object is natural. The inherent contradiction arises because if the data is accurate, the object cannot be natural. Conversely, if the object is indeed natural, then the data must be flawed. However, the data has undergone repeated scrutiny by multiple independent teams utilizing different instruments and methodologies, and the results consistently corroborate one another. So, where does this leave the researchers who find themselves unable to reconcile these conflicting interpretations? According to the aforementioned correspondence, they are being discouraged from exploring alternative explanations. While not explicitly forbidden or censored, such discussions are met with disincentives. Professional incentives are heavily weighted towards conventional interpretations. Scientific papers proposing exotic hypotheses face more stringent review processes. Grant applications that incorporate terms such as artificial or non-natural are often met with skepticism, potentially hindering career advancement. This phenomenon is not exclusive to the study of 3I Atlas. It represents a broader challenge within the scientific community. There is an inherent pressure to remain within established frameworks, to avoid disrupting the status quo, and to maintain a conservative approach to claims. While this inclination often serves a healthy purpose, preventing speculative theories from overshadowing robust empirical work, it can occasionally lead to blind spots, situations where empirical data points in one direction, while the broader scientific community directs its attention elsewhere. Jason Wright, an astronomer at Penn State University, has been notably vocal on this issue. He has expressed criticism of Avi Loeb's methodology, both in relation to 3I Atlas and previously concerning Oumuamua. Wright argues that Loeb is overly hasty in invoking artificial explanations and tends to dismiss fundamental observational evidence. He contends that while Loeb's claims garner media attention, they often falter under rigorous scrutiny. Wright articulated his concerns in a blog post, writing, "Avi has cultivated a reputation for proposing and outright asserting that certain phenomena could be alien spacecraft, even when there is minimal to no objective basis for such claims. It did not take long before Avi asserted that 3I Atlas was an alien spacecraft." He proceeds to critique specific assertions made by Loeb. For instance, the notion that the extended source observed by telescopes is merely a result of image smearing. Wright points out that modern telescopes are equipped with sophisticated tracking and image stacking capabilities that effectively compensate for object motion, rendering smearing a non-issue for professional observatories. If multiple independent observations consistently reveal an extended source, it is a genuine characteristic of the object. 3I Atlas does indeed exhibit a coma, a feature characteristic of comets. However, Loeb's response to such criticisms is more nuanced than Wright's critique suggests. Loeb is not asserting certainty. Rather, he proposes a framework, a scale ranging from 0 to 10, where 0 definitively signifies a natural origin and 10 indicates a definitive artificial source. He rates 3I Atlas as a 6 on this scale. The evidence is not conclusive, not proven, but substantial enough to merit thorough investigation. The proposed measurement system is particularly noteworthy. It's designed to shift the discourse from a simple yes-no categorization. Rather than asking, is it extraterrestrial or not? It poses, to what degree is it anomalous? It aims to quantify how much an object deviates from expected norms and to establish thresholds for different levels of anomaly that would trigger specific responses. Lowers has advocated for the formal adoption of this scale by an international body, specifically the United Nations. In October, a white paper was published, co-authored by Omdier Gersian, Tenenbaum, and Avi Loeb, titled Advancing Interstellar Science, a Global Framework for Comprehensive Study of Interstellar Objects. This document proposes the establishment of UNCIO, the United Nations Committee on Interstellar Objects. The underlying concept is straightforward. As our detection capabilities advance, particularly with the imminent operational status of the Vera Rubin Observatory, we anticipate discovering a significantly larger number of interstellar objects. Estimates suggest finding one such object every few months, potentially more. Each discovery presents a fleeting window of opportunity as these objects traverse our solar system rapidly. To effectively study them, a coordinated, international, rapid, and pre-planned approach is essential. UNCIO would serve to standardize responses, define protocols, create a network of observatories with guaranteed observation time, maintain a fleet of rapidly deployable spacecraft, and, crucially, implement the Loeb scale as the official classification system. Objects assigned a rating of 4 or higher would necessitate enhanced observation. A level 6 rating would mandate notification of the UN Security Council, while a level 8 or above would trigger emergency protocols. Currently, 3 Atlas is rated at a 6. Should it exhibit maneuvers, if gamma rays are detected, or if its activity persists independently of its distance from the Sun, its rating would increase, leading to a corresponding escalation in the international response. This proposal is ambitious, requiring funding, political will, and collaboration among space agencies, none of which are guaranteed. However, The foundational framework is in place, and Representative Anapolina Aluna, a U.S. Congresswoman, has lent her support, as evidenced by her letter of endorsement cited in the White Paper. The realization of UNCEO hinges on developments over the coming months. If 3 Atlas quietly recedes into interstellar space, the urgency will diminish, and it will likely become a curious case study, akin to an unusual comet, meriting a scientific paper but not a global crisis. Conversely, if the object exhibits unexpected behavior that defies conventional explanation, the narrative will shift, transforming the notion of international coordination from bureaucratic overreach to a critical necessity. Another significant factor at play is transparency, or the lack thereof. The information originating from the 4chan post suggests the existence of internal discussions not made public, data that has not been released, and unvoiced frustrations. If these claims are accurate, and there is a discrepancy between private scientific discourse and official statements, this gap will inevitably be bridged, either through unauthorized disclosures or formal revelations. The scientific method fundamentally relies on openness. Data should be shared, hypotheses rigorously tested in the public domain, and peer review conducted transparently. When these principles are compromised, when information is compartmentalized or controlled, trust erodes, and speculation rushes to fill the void. Currently, we find ourselves in an ambiguous, intermediate phase. Sufficient public data exists to prompt questions, but not enough to provide definitive answers. Crucial observations, such as the images from the Mars flyby, the gamma-ray surveys, and the trajectory measurements from December, are still pending. Within this observational gap, individuals are watching and waiting, some with telescopes, others with theories, and a select few, allegedly, with undisclosed knowledge. The subsequent chapter of this narrative will not be penned by conjecture, but by empirical data, observations, and measurements that will either validate the prevailing explanation or compel us to consider alternative hypotheses. We are nearing a critical juncture. The Mars flyby has already occurred. The perihelion approach is just 3 weeks away, and the object's reemergence in December is 2 months out. By the close of the year, our understanding will be significantly enhanced, though perhaps not entirely complete. Should the anomalies persist, and should the data continue to defy conventional interpretations, then the silence protocol, irrespective of its form, will eventually falter. The barriers we erect around disconcerting questions inevitably begin to crumble, revealing the underlying reality, whether we are prepared to acknowledge it or not. Chapter 10. What transpires next? The imagery captured during the Mars flyby is expected within days, possibly a week. The Mars Reconnaissance Orbiter has successfully transmitted its data back to Earth. Engineers are currently engaged in processing, calibrating, and enhancing these images. Soon, we will ascertain what the high-resolution observations revealed during the flyby. If the nucleus is clearly discernible and measures 5 kilometers or more in diameter, the significance of the object will intensify. The estimate of 33 billion tons will become considerably more difficult to disregard. The statistical improbability of encountering an object of such magnitude would become undeniable. This would imply either that interstellar space is far more densely populated than previously assumed, or that this object possesses exceptional characteristics that elude our current comprehension. Conversely, if the nucleus is smaller than 1 kilometer, the enigma shifts. A diminutive nucleus expelling such a substantial volume of gas and maintaining such brilliance at this distance presents a distinct set of challenges. It suggests extraordinary internal activity, internal heat generation, or an underlying mechanism driving the emissions beyond mere solar warming. Either scenario raises profound questions. Neither provides a definitive resolution. The spectroscopic data acquired by Mars Express and ExoMars Trace Gas Orbiter will introduce another dimension to our analysis. These instruments are measuring the gas composition from a closer vantage point, utilizing instruments specifically designed for atmospheric study. If they detect compounds not visible from Earth-based telescopes, or if the chemical signatures appear even more unusual upon closer inspection, this will be a significant development. Furthermore, the brightness monitoring is crucial. As 3 Atlas departs from Mars and continues its trajectory towards perihelion, observers on Earth face a progressively narrowing observational window. By mid-October, the object will become obscured by solar glare. Until then, every night of photometric data, every recorded spectrum, and every polarization measurement is invaluable. Research teams worldwide are meticulously collecting and archiving this data, constructing a chronological record. Upon the object's reappearance in December, this timeline will become paramount for comparison. We will contrast its pre-perihelion behavior with its post-perihelion activity. Will its behavior curve align with predictions, or will it deviate? A typical comet adheres to a power law relationship, with brightness and gas expulsion increasing inversely with the square of its distance from the Sun, or even more rapidly. As it approaches the Sun, its activity escalates. As it recedes, it diminishes. This behavior is predictable and universal. If 3I Atlas fails to conform to this pattern, if its activity remains high as it surpasses 3 astronomical units, and then 4, this would constitute a significant red flag. The Q prediction, as previously mentioned, is contingent upon this behavior. An internal energy source would operate independently of solar distance, exhibiting constancy. This is a falsifiable and testable hypothesis. We should have an answer by January or February. The ongoing gamma-ray search represents another vital investigative avenue. Observatories such as Fermi and Integral continuously scan the celestial sphere, detecting high-energy photons. If 3I Atlas harbors an internal particle physics process, a decay mechanism generating high-energy particles, these instruments should register it. To date, there have been no public reports of gamma-ray emissions emanating from 3 Atlas. This does not preclude the possibility that such searches are underway. Data analysis requires time, signals can be faint, and background noise levels are considerable. A detection might not be immediately announced, or it could be present within a dataset awaiting discovery. If gamma rays are detected, and if they can be correlated with the comet's position, and if they cannot be attributed to solar-wind interactions or cosmic ray impacts, this would represent a paradigm shift. No natural comet emits gamma rays through internal processes. Such emissions are characteristic of astrophysical engines like pulsars, magnetars, supernovae, or potentially exotic matter. The subtle perturbations to Mars' orbit constitute a more gradual indicator. Mars' orbital path is tracked with exceptional precision, known to within meters. If 3 Atlas exerted a gravitational influence during its close approach, Mars would deviate slightly from its predicted trajectory. While the displacement might be minimal, perhaps millimeters per day, this cumulative effect over months would become measurable. By early 2026, any deviation, if present, should be quantifiable. Should this deviation align with the expected gravitational perturbation from an object weighing 33 billion tons, this would provide independent confirmation of its mass, rendering outgassing chemistry irrelevant. The UAP monitoring via the Galileo Project observatories is currently active, with data being collected in real time. If an increase in unexplained aerial phenomena coincides with the perihelion passage, it will be evident in the statistical analysis, indicating a higher number of objects, unusual trajectories, or clustering in time. The absence of such a spike would not invalidate the decoy hypothesis, but would eliminate one line of supporting evidence. However, the presence of a spike would be difficult to dismiss, particularly if the anomalies are concentrated in late October and early November, subsequently diminishing. Furthermore, December 5th marks the conclusion of Lowe's specified detection window for trajectory modifications. If 3 Atlas executed a maneuver during its perihelion passage, perhaps initiating a retrograde burn to remain bound to the solar system, this deviation should be detectable by that date. Observatories will meticulously measure the object's position and calculate its orbit in comparison to predictions. If the orbit remains unchanged, purely influenced by gravity, then no maneuver occurred. The object simply passed through perihelion naturally and is now departing, regardless of its true nature. However, if the orbit has altered, exhibiting a deviation unexplainable by outgassing or fragmentation, then an event transpired behind the sun, concealed from our view, demanding a comprehensive explanation. The Vera C. Rubin Observatory introduces a final, crucial element. Its operations commenced this year, featuring comprehensive sky surveys, deep imaging, and automated detection capabilities. It is specifically engineered to identify transient celestial objects, including moving bodies such as asteroids, comets, and interstellar visitors. Current models predict that Rubin will detect one interstellar object every few months, or possibly more. Within a year or two, we will possess a dataset comprising dozens of such objects, each serving as a data point for comparison. This will allow us to determine whether 3I Atlas is an anomaly or representative of a larger population. If subsequent interstellar objects exhibit similar anomalies, extreme mass, unusual chemical composition, or consistent brightness, then 3 Atlas will not be an outlier, but a precursor, an initial glimpse into a common galactic phenomenon that we are only now beginning to perceive. Conversely, if future objects are all unremarkable, small, and behave like conventional comets, 3 Atlas will stand apart as an exception, rendering it even more enigmatic. The broader context is one of a pivotal moment. For the first time, humanity possesses the sophisticated tools necessary to conduct detailed studies of interstellar visitors, moving beyond mere detection to in-depth analysis. This includes spectroscopy, high-resolution imaging, rapid response missions, and international collaboration. 3 Atlas is effectively a stress test, pushing the limits of every instrument, model, and assumption. In doing so, it exposes deficiencies in areas where our understanding is less robust than we believed. Some of these gaps will undoubtedly be bridged through improved data, refined theories, and the discovery of natural explanations that have not yet been considered. Science possesses an inherent capacity to resolve anomalies, though not always instantaneously. Other gaps, however, may not be closed. They might widen into chasms, fundamentally altering the discourse from "what kind of comet is this?" to "what is this?" We have not yet reached that point, but we are sufficiently close to perceive the precipice. The ensuing 3 months will be highly revealing, encompassing the Mars imagery, the perihelion passage, gamma-ray surveys, the December reappearance, trajectory measurements, and UAP data. Each piece of information will either contribute to a clearer picture or further complicate the puzzle. By the time we reach March, when 3I Atlas passes Jupiter and the Juno spacecraft conducts its close observation, we will possess a considerably more defined understanding, not entirely complete, but substantially clearer. If by then, the object continues to defy explanation and remains at a lobe scale rating of 6 or higher, the silence protocol will be breached. The questions will become too persistent, the data too compelling, and we will be compelled to confront the possibility, as suggested by the 4chan leaker, that this is not a failure of our models, but rather an indication of something underlying them, something previously unknown. Whether that something is exotic astrophysics, dark matter, ancient remnants, or an entirely different phenomenon, we are on the verge of discovery. The universe is patient. It does not act hastily, nor does it conceal its secrets indefinitely. If 3 Atlas harbors a hidden mechanism or an underlying structure, it will reveal itself through the data, through observations, and through the gradual accumulation of evidence that either corroborates or refutes. Our role is to observe, to wait, and to remain receptive to following the data's trajectory, even if it leads to uncomfortable conclusions, for that is the essence of science. Not a collection of answers, but a methodology for formulating more profound questions. And 3IE Atlas is posing one of the most significant questions we have encountered in a considerable time. What are you? Thus, we arrive at the conclusion of a narrative that is far from over. October 3rd, 2025. The Mars flyby concluded mere hours ago. Data is being transmitted, and within that data may lie an answer, or at least the genesis of one. Let us pause and reflect on what has been examined. 3 Atlas, an interstellar visitor, marking the 3rd confirmed instance of such an encounter. However, unlike its predecessors, this object exhibits behavior that defies conventional understanding. It expels approximately 150 kilograms of material per second without any discernible recoil. Its mass is estimated to be that of a small moon, compressed into a volume comparable to Manhattan. It emits nickel at temperatures where nickel should remain in a solid state. Its spectral analysis reveals the presence of nickel tetracarbonyl, a synthetic industrial chemical. The dust it disperses exhibits polarization characteristics so extreme that scientists initially suspected instrument malfunction. It does not appear to rotate, or if it does, its brightness remains constant. It absorbs gigawatts of solar energy, yet maintains a remarkably low temperature. Furthermore, its trajectory, its timing, and its alignment with planetary bodies present probabilities that are statistically unsettling. 7 anomalies have been identified, 4 that might be reconciled with natural phenomena, and 3 that persist irrespective of the volume of data collected. Adding to this complexity is the leaked information. An anonymous post, purportedly from an individual affiliated with the European Space Agency, describes the insurmountable difficulty of reconciling this object with any known natural celestial body. It speaks of chemical compositions that should not exist on a celestial body billions of years old, dust particles that appear artificially manufactured, and a thermal budget that fails to balance. The leak suggests a conclusion that has been discouraged from public discourse, that this object might not be debris at all. This leads to the cue ball hypothesis, a macroscopic quantum object originating from the Big Bang, a bubble of alternate physics encased in ice and dust, gradually decaying over eons. This hypothesis posits an internal energy source independent of solar influence, producing exotic chemistry as exhaust, with symmetrical and violent outgassing resulting in zero net thrust. While this sounds like science fiction, according to the leak, it represents the sole framework capable of harmonizing all the collected data. It is the only physical model that transforms a series of inexplicable anomalies into a coherent, testable theory. Two predictions arise from this hypothesis, both simple and falsifiable. First, observe the object as it departs the solar system. If its activity level remains high, irrespective of its distance, this would be the initial indicator. Second, direct a gamma-ray telescope towards it. The presence of a non-thermal high-energy signature would provide the second confirmation. Both predictions are scheduled for verification in the coming months. There is also the concealed window of observation. In 26 days, 3I Atlas will disappear behind the Sun. Perihelion is scheduled for October 29th, an ideal moment for a maneuver, assuming maneuvers are feasible. It would also be the perfect juncture to deploy probes, should such probes exist, and we will be unable to witness any of these events. We will not have visual confirmation until December, when the object reemerges and we can reassess its trajectory. Did it change? Did something occur? The decoy theory introduces another layer of complexity. It suggests that the comet might serve as a diversion, a conspicuous phenomenon drawing attention while genuine reconnaissance operations are conducted closer to Earth. The Galileo project is actively monitoring for such activity. 3 observatories are scanning the sky, searching for an increase in unexplained phenomena coinciding with the perihelion passage. If such activity is present, the data will undoubtedly reveal it. Beneath the surface of these observations, the scientific community is undergoing a subtle fragmentation. This is not openly apparent in press releases, but is observable in more private exchanges. Some scientists maintain that 3 Atlas is simply an unusual but natural comet. Others, confronted with the data, find it impossible to reconcile with known natural bodies. This cognitive dissonance is becoming a significant professional challenge, according to the leak, and the official silence from leadership is becoming increasingly pronounced. A formal proposal has been put forth. UNCEO, the United Nations Committee on Interstellar Objects, designed to foster international cooperation. This framework includes the Loeb scale as the official classification system, protocols for rapid response, observational networks, and even spacecraft on standby for immediate deployment upon the arrival of the next interstellar visitor, as the Vera Rubin Observatory guarantees future encounters. These future objects will arrive at a rate of 1 every few months, perhaps more. Each presents either an opportunity or a warning. 3 Atlas is currently assigned a rating of 6 on the Loeb scale, high enough to mandate thorough investigation, but not yet sufficient to trigger emergency protocols. However, if the predictions hold true, if gamma rays are detected, if the trajectory undergoes alteration, or if the object's activity persists, its rating will escalate, and the discourse will intensify. We are on the cusp of significant revelations. Within the next 3 months, possibly sooner, data will emerge that will either validate the conventional explanation or compel us to embrace alternative hypotheses. The images from Mars will clarify the size of the nucleus, whether it is substantial or diminutive. Spectroscopic analysis will refine our understanding of its chemical composition. Trajectory measurements in December will determine whether any events transpired behind the Sun. Gamma-ray searches will either yield a definitive signal or rule out such emissions. The Galileo project will either detect a UAP surge or its absence. By spring, when 3 Atlas traverses Jupiter's orbit and the Juno spacecraft performs a close examination, we will possess a comprehensive data set sufficient to assert with confidence what this object is, or at least what it definitively is not. The universe does not deceive. Its secrets are not hidden indefinitely. If 3 Atlas is merely a comet, albeit an anomalous one, the data will converge toward that conclusion. The anomalies will be resolved, the models will be adjusted, and we will move forward. However, if the data continues to resist conventional interpretation, if each new observation introduces further strangeness, and if the pattern of anomalies deepens and persists, then we must follow its implications, even if they prove uncomfortable, even if they challenge our fundamental understanding of what drifts through the interstellar void. This is the inherent promise of science, not comfort or certainty, but truth, regardless of its unexpected nature. Thank you for your attention and for staying with this narrative through its numerous twists and the accompanying uncomfortable questions. If you found this valuable, please consider liking this video and subscribing if you haven't already. Your support is immensely helpful. In the comments section, please share your thoughts. Are you convinced this is simply a comet, or do you perceive elements that do not align with conventional explanations? What do you believe we are observing? This video is intended for entertainment and educational purposes. The views expressed, particularly concerning the 4chan leak and speculative theories, do not reflect scientific consensus. For verified information, always consult peer-reviewed academic sources and official statements from space agencies. Until our next encounter, continue to gaze at the heavens, for something is indeed traversing the darkness. And within a few short months, our understanding of its nature will be significantly enhanced. Good night.